Hello. In a recent video I spent a few moments just thinking more generally about the R formulas. And in this video I thought I'd work on an example that I've quickly pulled from a textbook that I have, and states, given that 5 sine theta plus 12 cos theta equals r sine theta plus alpha, find the value of r is greater than 0, and we're also asked to find the value of tan theta. And so in the last video we thought about a little bit about R formulas more generally. And so in this video just maybe work on an example. This one I think is going to be too simple, but it very much will be very simple, but we'll offer some context at least. And so to rewrite this, we've got an identity 5 sine theta plus 12 cos theta is the same as or identical to r sine theta plus alpha. And again, one's intuition or instinct might be to work on the left hand side. It looks a bit more simple, right? It looks, I guess, a little bit more digestible. But what you want to do, what one want to do, is to expand on the right hand side, which is and again we can just expand this out just as we would angle sum formula for sine. And so what we would get is r sine theta cos alpha plus r cos theta sine alpha. And from here what we can do is actually just we still have on the left hand side all of this here, so let's just rewrite everything. Get 5 sine theta plus 12 cos theta. Got this identity where r sine theta cos alpha plus r cos theta sine alpha. And so again, what we want to do is we want to equate the two, and in doing so we can rewrite, well, we can simplify, or we essentially form a system of equations, right? Because if 5 sine theta is equal to r sine theta cos alpha, well, 5 then has to be equal to r cos alpha. Likewise, 12, if as we're equating them, if 12 cos theta is equal to 12 cos theta, or r cos theta sine alpha, well then 12 has to be equal to r sine alpha. Now we have our system of equations. We can label them 1 and 2, and we want to divide equation 2 by equation 1, which is going to give us 12 equals r sine alpha, and over 5 equals r cos alpha, which of course is going to equal, if we divide equation 2 by 1, we're going to get 12 over 5 equals tan alpha, or we could solve for alpha if we want, which would be arctan 12 over 5, which I think is 60 something degrees. One could easily find out. We don't need to for the sake of this question. We just need to find the value of tan alpha, which we've already found. It's I think 60 something degrees in this case. So and then for r we need to find the value of r, and remember that r always equals a squared plus b squared, or equation 1 squared plus equation 2 squared. That's how I like to remember it anyways, equation 1 squared plus equation 2 squared, because we always tend to have, or often have, a system of equations like this, and it's just much easier to remember. So we get r equals, well, what is equation 1 squared plus equation 2 squared? We get 5 squared plus, got 12 here, so 12 squared equals r squared cos squared alpha plus r squared sine squared alpha. So we can simplify, and this is just the concluding part. Really, it's simple. 5 squared is 25, 12 squared is 144. You add them, you get 169. We know the square root of 169 is 13, and so one might predict the value of r already. But I'll just go through the steps here, because we have r squared as a common factor, so we can factor that out, and then we get cos squared alpha plus sine squared alpha. This is of course a very basic Pythagorean identity, which equals 1, and so we just end up with r squared equals 169. Take the square root of both sides, and r does indeed equal 13, or sorry, plus or minus 13, positive or negative, and I believe it says here, yeah, at this the question, r is greater than 0, therefore r is 13, and that would be our answer.